So in the last class we were discussing about the concept of the pressure belt. We started with the concept of pressure belt. Along with that, we have also covered the concept of lapse rate in the last class. What is environmental lapse rate? What is the other kind of lapse rate like adiabatic lapse rate? So those lapse rate we have covered in the last class. Also, what are the factors which are affecting the temperature distribution on Earth's surface? Those concepts we have taken up in the last class. So, which if atmosphere is not transparent to the sunlight, what will happen? If atmosphere is not transparent to sunlight, what will happen? If atmosphere is not transparent to sunlight, what will happen? We discussed three scenarios, no? When sun's wavelength is greater than what? Radius of obstructing particle. When sun's wavelength is equals to what? Radius of obstructing particle. And when sun's wavelength is lesser than radius of obstructing particle. So what are the scenario? When sun's wavelength is greater, then what will happen? It will scatter, yes. When it is equal, then what will happen? Absorption. And when it is lesser, what will happen? Reflection. Okay, so those concepts we have discussed. Atmosphere is not transparent. Fine. Then we also discussed what are the other factors which affects temperature distribution. What are the other factors which affect temperature distribution?
Duration of sunshine.
Yeah. What is the duration of sunshine? And
angle of inclination of solar radiation.
yeah, angle of inclination. Then
Prevailing winds.
prevailing winds. Fine. Then
Aspects of slope.
aspect of slope. Yes, one slope will get more heat, one slope will not get more heat. Then
Land and sea differentiation.
yeah, land and sea differentiation. So then
Oceanic currents.
oceanic current. Yes, and
Altitude.
altitude.
Solar insolation.
Yeah, those are the factors that are affecting temperature distribution. Now, which type of lapse rate is highest? Which type of lapse rate is highest? Which type of lapse rate is highest? Dry adiabatic lapse rate or environmental lapse rate or wet adiabatic lapse rate? Dry adiabatic lapse rate is highest, then followed by whom? Followed by environmental lapse rate, then followed by wet adiabatic lapse rate. Fine. What is lapse rate means?
At what rate the decline in temperature is happening?
At what rate the decline in temperature is happening? In which type? In which scenario you will see environmental lapse rate? In which scenario you will see adiabatic lapse rate? In which scenario environmental lapse rate? In which scenario adiabatic lapse rate?
In unsaturated.
We discussed when non-rising air is there, then what will happen? Environmental lapse rate. When rising air is going to be there, then what will happen? Adiabatic lapse rate. And if the rising air is unsaturated, then dry adiabatic. If rising air is saturated, then it is going to be what? Wet adiabatic. Fine. So we started with the concept of pressure belt, and we discussed what is pressure belt. What is pressure? What is pressure? We discussed force per unit area. What is the pressure we have discussed? Force, it is force per unit area. So we discussed when there is a uniform pressure. When there is a uniform pressure, let's say this is India, when there is a uniform pressure throughout a region, then it is going to be called as what? It is going to be called as a pressure belt. And we discussed why there is a pressure. Why there is a pressure? Because the atmosphere consisting of gases. Atmosphere is consisting of gases. These gases have certain weight, and because of these weight, what will happen? Air pressure is going to be there. Atmosphere is consisting of certain gases. Since these gases has weight, what will happen? You will see pressure. So this is what you are finding with regard to why there is a pressure. Clear? And when there is a pressure is uniform throughout a region, it is going to be called as what? It is going to be called as a pressure belt. Fine. The third thing that we have discussed is that there are two movement of the air. One is called as a horizontal movement, and another is called as a vertical movement. Horizontal movement is called as what? Wind, and vertical movement is called as what? Air current. So we discuss horizontal movement of wind is horizontal movement of air is called as a wind, and vertical movement is called as a air current. We discussed in the last class that we do experience wind, but we do not experience what? air current. Why we do not experience air current? Because it is balanced by whom? It is balanced by the gravitational effect. So air current, we don't feel the air rising from nothing but okay bottom to the top. It is because it is balanced through what? Balanced through the gravitational effect. So that part we have discussed in the last class, and we discussed how much is the air pressure at the sea level. How much is the air pressure at the sea level? We have discussed it is 1034 gram per square centimeter. So this is what we have discussed with regard to term air pressure. Fine. Now air pressure is also measured. The unit of air pressure is also as a bar. Bar is also the unit of air pressure. Either gram per centimeter. Okay, you can measure in this, or you can measure. Okay, instead of this, you can write as a bar. For example, like force is called as what? Mass into acceleration. Mass unit is what? Kg. It is meter per second square. So this is also the unit of force, but we write what as the unit of force also? Newton. So Newton is also considered as a unit of force. Okay, that is okay there. Likewise, bar is also considered as a unit of pressure. Fine. So that's why there is a term called isobar. That's why there is a term also called isobar. Like we have discussed isotherm. What was isotherm? Yeah, it is a line connecting the places with equal temperature. It is line connecting places with equal temperature. So when we are connecting line connecting places with equal pressure is going to be called as what? Line connecting places with equal pressure. Places with equal pressure is referred as what? Is referred as a isobar. So line connecting places with equal pressure is referred as a isobar. Again, this line is drawn where? On the map, and it is again which type of line? Imaginary line. We draw it in order to study. So isobar is a line connecting places with equal pressure, and these lines are drawn where? These lines are drawn on a map, and again it is which type of line? It is imaginary line. Fine. So the same thing what we have discussed with regard to isotherms also applies to whom? Also applies to the isobar. Fine. Whatever we have discussed with regard to isotherms is also applies to whom? Also applies to isobar. So what are the properties of isotherms we have discussed? What are the properties of isotherms we have discussed? That isotherms, if they are closely placed, what will happen? What will happen? It indicates rapid decline in what? Rapid change in what? Rapid change in temperature. And if isotherms are widely placed, then what will happen? Widely placed, then we discussed there will be what? Slow change in temperature. This is what we have discussed regarding the characteristic of isotherms. The third characteristic we have discussed is whenever you are moving from land to sea or land to oceans, there is a sudden bending observed in what? Sudden bending observed in isotherms. There is a sudden bending observed in isotherms. These are the properties we have discussed with regard to what? Isotherms. Fine. So remember we discussed isotherms shifting northward or equatorward at the oceans and other things we have discussed in the last class. So these are the properties we have discussed with regard to isotherm. The same properties also applies to whom? The same properties also applies to whom? Applies to isobar. Same properties also applies to isobar. So isobar also is what? If the isobar are closely placed, then it indicates what? Rapid changes in pressure. Then it indicates rapid changes in pressure. If isobar are widely placed, that indicate what? Slow changes in pressure. Slow changes in pressure. And the third that you have is what? The land, sea. Whenever you are moving from land and sea, sudden bending will be observed in isobar. Sudden bending is observed in isobar. Fine. So same properties what we have discussed with regard to isotherms also applies to isobar. Isobar, if they are closely placed, as we discussed, this line is closely placed, it indicates rapid changes in pressure. If this line is widely placed, it indicates slow decline in pressure. And land sea differentiation means whenever we are moving from land towards the sea, you'll see a bending being observed. You'll see a bending being observed, and this is called as what? This is called as the properties of isobar. Fine. So what is isobar? It is a line connecting places with what? Equal pressure, and you'll have the closely placed, widely placed, as well as land sea differentiation. Fine. Fine. Now, coming to this concept of pressure belt. So, as we discussed, there are how many pressure belts we have discussed? Prominently 4 major pressure belt. What are the 4 major pressure belt? Equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, and polar high pressure belt. Those are 4 major pressure belt, and these are also repeated in what? These are also repeated in a southern hemisphere. And we have discussed extension. How much is extension of equatorial low pressure belt? 10 degree north to 10 degree south. Then you have subtropical high pressure belt extending from 23.5 degree to 35 degree. Then you have 45 to 66.5. This is okay. Extension of subpolar low pressure belt. And finally 80 to 90 degree. You have an extension of the polar high pressure belt. Fine. So we classify this pressure belt into 2 parts. We classify this pressure belt into 2 parts. They are referred as thermally induced pressure belt, and dynamically induced pressure belt. Thermally induced pressure belt and dynamically induced pressure belt. Fine. Which are the thermally induced pressure belt? So 2 pressure belts are thermally induced: equatorial low pressure belt and polar high pressure belt. These are referred as a thermally induced pressure belt, while 2 pressure belts are referred as a dynamically induced pressure belt, which are your subtropical high pressure belt and subpolar low pressure belt. So you have 2 pressure belt which are dynamically induced: subtropical high pressure belt and subpolar low pressure belt. 2 belt are thermally induced. Thermally means what? Because of temperature change. It is thermally induced. So equatorial low pressure belt and polar high pressure belt is generated due to temperature difference, while it is generated due to dynamic reason. Fine. So what is the reason why you see more development of these pressure belt, and why thermally induced and why dynamically induced pressure belt are being developed? Now we are going to discuss that particular aspect. Fine. So the first we are going to take up is how the equatorial low pressure belt are being developed. Now let's say this region which is 10 degree north to 10 degree south, this is equatorial region. So this is which region? Equatorial region. You know that equatorial region receives maximum amount of what? Sunlight. It receives maximum amount of sunlight. So when maximum amount of sunlight is there, what will happen to this region? This earth is receiving maximum amount of sunlight, so earth here will get heated. So what will happen to the air? Air that is in contact with the earth, it will also get heated. Here, air in contact with the earth will also get heated. So when air in contact with the earth will get heated, what will happen? This air is what? This air is going to expand. So you know that anything is heated, what will happen? Expansion happens. So you will see rise of air current. So air will move upward. Fine. So you will see expansion of air. Air will starts to move up. Air current will move up. Fine. Now, as you go up in troposphere, what happens? As you go up in troposphere, what happens? Temperature decreases. So if temperature decreases, what will happen? If temperature decreases, what will happen? Whatever the moisture that are present in this air, what will happen to these moisture? What will happen to these moisture that are present in the air? What will happen to these moisture? These moisture will starts to what? This moisture will starts to condense from water vapor form. They will condense into what? They will condense into water form. Fine. So as a result, you will see formation of what? You will see formation of clouds. Here clouds and rainfall. So you will see condensation happens, and after condensation, what will happen? You will see the rainfall is going to happen in this particular region. Fine. So as the air moves up, why the air is moving up? Because equatorial region is heated, so air will also get heated. When air will heated, what will happen? It will rise up. When it will rise up, what will happen? As the temperature will decrease, what will happen? Moisture that is present in the air will condense, and this moisture will create a cloud and create a rainfall. Clear? Now, we discussed just now that whenever anything is converting from vapor to water state, that is liquid state, what is being released? What is being released? Whenever anything is converted from vapor to liquid state or the gas state to the liquid state, what is being released? What is being released? Last class we talked about something called latent heat. What was latent heat?
Changes the shape.
Changes the
State of
state. Yes. Okay. So we discussed latent heat is the heat which is required to change the state. Clear? Two types of heat we have discussed: specific heat and latent heat. Specific heat is the amount of heat required to raise the temperature of a body by 1 degree Celsius, and we discussed latent is the heat absorbed when a state is being changed. Like we discussed, when you are heating ice, what will happen? Ice will first reach its temperature to 0 degree, then whatever heat you are supplying, ice will use this heat to convert into what? Liquid state, because 0 degree is melting point. So whatever heat is being absorbed at that point is called as what? Is called as a latent heat. So when vapor is converting into water, what heat is going to be released? Latent heat is going to be released. This heat is released. So when you are moving from water to vapor, what will happen? Latent heat is going to be absorbed. But when you are moving from vapor to water, what state is going to be released? What heat is going to be released? Latent heat is going to be released. Fine. So when this condensation is happening, vapor is converting into water. What is happening? Latent heat is released. When latent heat is being released, what will happen? It will further heat the air. As a result, you will see further rise up of air, because the heat that is being released is warming the air, and this air will further rise up. Fine. You know that when anything is heated, what will happen? Expansion will happen. So since heat is released, it is going to further rise up. Fine. But this will be which type of air? This will be dry air. While this is which type of air? Moist air. Because it has lost its moisture. Rainfall has happened. So what will happen? This air has now lost its moisture. So that's why which air is going to rise? Dry air is going to rise. Fine. Any doubt regarding this particular part? Now, as we discussed, when it reaches towards, let's say, assume this is a tropopause. This is a tropopause. Now, when air reaches to this point, what will happen to the air? What will happen to the air? Can it rise in stratosphere? Will this air will rise in stratosphere? The air is reaching till the top of tropopause. Will the air will rise in stratosphere? Temperature will increase in?
Temperature increase in stratosphere.
So what?
So air will mix in the particles and
Air will mix the particles.
mixing in the particles and it will.
Fine. Anyone else? Anyone else? So as we discussed, at this point what will happen? At this point you'll have what? You'll have nothing but okay, here lower temperature, but as you go in a troposphere, what is happening? Temperature increases. So as you go up in stratosphere, what will happen? Temperature increases. So here which type of temperature is there? Here higher temperature is there. In stratosphere we discuss as you go up what will happen? Temperature will increase. So here higher temperature is there, here lower temperature is there. When higher temperature is there, then what will form? High temperature is there, then what will form? Low pressure, and lower temperature is there, so which pressure will form? High pressure. Okay, lower temperature means we discuss high pressure, condensation is happening, high pressure is going to form, and high temperature means expansion will happen, heating will happen, so low pressure is going to be formed. Clear? Which air is okay? What? Which air is going to be more dense? This air is going to be more dense, or this air is going to be more dense?
High pressure.
High pressure air is going to be more dense. What density is what? Mass by volume. So remember we discussed volume is directly proportional to what? Temperature. So if temperature decreases, volume will decrease. If volume will decrease, what will happen to density? Density is going to increase. So if volume decreases, what will happen to density? It will increase because inverse relationship is there. Fine. So what will happen is okay, which air is more dense? This air is more dense, and you know that always less dense is going to float over what? Less dense is going to be floating over more dense. Clear? So since this air is more dense, it will not rise up. This air is less dense. So this less dense will always be floating over what? Floating over more dense. Clear? So that's why air will not rise up in which air? In which region? It will not rise up in the case of stratosphere. It will not go in the stratosphere. Fine? Any doubt regarding this particular thing? So when it is heated in the equatorial region, you see rise of air, and this air is what? Condensing. This air is condensing, forming a cloud. Rainfall is happening. This releases which type of heat? Latent heat. Latent heat further heat the air. As a result, air will further rise up, but this air will not go into stratosphere. Why? Because here the air is less dense, here the air is more dense, and you always know that less dense will always be moving over more dense. Fine. So as a result, what will happen to the air? So what will happen to this air? Now this air will start to move and bifurcate like this. This air will start to move and bifurcate in these two directions. Clear? Because it can't move up. So what will happen? It will start to move in this direction, that is okay there. Clear? Now when the air will travel in upper direction, what will happen? What will happen? When the air is closer to the earth, what is happening? It is getting heated. But when air is traveling away from the earth, what will happen? It cools down. Here what will happen? As you are going up, what is happening? Temperature is decreasing, no? So when temperature is decreasing, what will happen? This air becomes cold air. This air becomes which type of air? This air becomes cold. Why it becomes cold? Why it becomes cold? Because as you are going up in troposphere, what is happening? Temperature is decreasing. So this air will become cold when it is traveling in upper atmosphere. When it becomes cold, then what will happen to air? Colder air is which type of air? Dense air. Okay, just now we discussed colder air is which type of air? Dense air. So denser air will come down. Lighter air will what? Goes up. So as a result, this air starts to come down. Because it is more dense, it starts to come down like this. This starts to come down like this. Okay? So when the air is traveling in upper atmosphere, you will find air becoming more dense. When air becoming more dense, why air is becoming more dense? Because of decline in temperature, air is becoming more dense. When it is becoming more dense, what will happen? It starts to come down. It starts to come down. And this happens at which region? This happens at a subtropical high pressure belt. That's why it is referred as which type of belt? Subtropical high pressure belt, and this is referred as which type of belt? Equatorial low pressure belt. Here air is rising, expansion is happening, that's why low pressure, Here what is happening? Air is coming down. Compression is happening. When air will come down, what will happen? Compression will happen. When compression will happen, what will form? Subtropical high pressure belt is going to be formed. Clear? What is going to be formed? Subtropical high pressure belt is going to be formed. So that's why one in northern hemisphere, one in southern hemisphere, that you are seeing formation of subtropical high pressure belt. Fine. So what happens is air rising up, not able to rise in case of stratosphere. Air will diverge. They will diverge when they are moving in the upper atmosphere. What will happen? They will cool down. When they will cool down, they becomes heavy, denser, and they starts to come down. This coming down happens in which region? This coming around happens in a subtropical high pressure belt region. This is happening in a subtropical high pressure belt region. Fine. Any doubt regarding this particular part? So
Previous slide, sir.
move to previous slide. Right. This one. Next.
So this is thermally induced pressure belt, so the entire concept.
Which?
The diagram which you have.
No, this is thermally induced. Equatorial low pressure belt is which pressure belt? Thermally induced, because here it is being heated more, so air is rising up. Clear? But subtropical high pressure belt is not thermally induced. It is okay. It is dynamically induced. Why the high pressure is formed over here? Because air is moving in upper atmosphere. When it becomes denser, what is happening? It starts to come down. So when it is starting to come down, what will happen? It is forming a high pressure. So subtropical high pressure belt is not a thermally induced pressure belt. It is okay. Which type of pressure belt? Dynamically induced pressure belt. Why it is dynamically induced? Because air is rising from here. It is moving in this direction, and then okay, what? Then subsiding in which region? Subsiding in the subtropical high pressure belt region. Fine. So subtropical high pressure belt is a which kind of pressure belt? It is a dynamically induced pressure belt. Fine. Now you know that from when there is a high pressure to low pressure, always a wind will flow. You know that wind always moves from where to where? From high pressure region to low pressure region. So from here to here, you will see a blowing of wind. From here to here, you will see a blowing of wind. This wind is going to be called as what? This wind is going to be called as a southeast trade wind or northeast trade wind. Which type of wind it is called as? Northeast trade wind and southeast trade wind. So in northern hemisphere, we call it as which type of wind? In northern hemisphere, we call it as a northeast trade wind. In southern hemisphere, we call it as which type of wind? Southeast trade wind. So wind always blow from where to where? Always wind blows from where to where? From high pressure region to low pressure region. So when high pressure is formed over here, from here to here wind will blow. From here to here wind will blow, and this wind in the southern hemisphere is called as a southeast trade wind. In the northern hemisphere, this wind is called as what? Northeast trade wind. Fine. Fine. Now, as we discussed, air here is subsiding. Which type of air is here is subsiding? Which type of air here is subsiding? Denser air. It is which? What nature it is? Dry air. So when dry air is coming down, what will happen? Will rainfall will happen?
No, sir.
No. So that's why subtropical high pressure belt region do not experiences rainfall. It do not experiences rainfall because here dry air is something that is coming and subsiding. Here dry air is something that is coming and subsiding. So that's why you don't see rainfall in this particular region. You'll see rainfall in equatorial region, but you don't see rainfall in what? In case of nothing but okay, tropics region, subtropical high pressure belt region, because dry air is something that is okay coming and subsiding. That's why we say that here anticyclonic conditions are formed. Anticyclonic conditions. This region is referred as what? Anticyclonic condition. Anticyclonic means no rainfall will happen. Fine. Anticyclonic means no rainfall will happen in this region. Why no rainfall is happening? Because dry air is coming and subsiding in this particular region. Fine. Fine. Any doubt regarding this particular thing? That's why if you remember when we were discussing about deserts, we discussed what is the reason deserts are formed. Most of the deserts are formed in 15 to 30 degree latitude, remember? So we discussed one reason we have written it is a zone of what? High pressure, and second we have written is what? That oceanic current always, cold oceanic current moves where? On the western side. So cold oceanic current moves on the western side. So like we discussed here, you'll find Sahara Desert. Why Sahara Desert over here? Cold oceanic currents are there. And this lies in which region? This lies in a tropics region, high pressure belt region. This lies in which region? This lies in a high pressure belt region. So high pressure belt region, no rainfall will happen. When no rainfall, what will happen? What will form over here? Deserts are going to be formed over here. So that's why if you remember, we have written one, okay, what? One condition as that tropics region is a zone of high pressure belt region, and when there will be high pressure, there will not be any rainfall, anticyclonic conditions are going to be formed. That's why deserts are being found in a 15 to 30 degree latitude. Fine. Now, again from here to here, as we discussed, high pressure to low pressure, wind is blowing. So what will happen? You will see wind is blowing like this. Now this is a high pressure zone. From here again a wind will also blow in this direction. Like this, okay? You will see a wind is also blowing in this direction, and this wind is referred as what? This wind is referred as a westerlies. This wind is referred as what? This wind is referred as a westerlies. So from high pressure, wind is blowing to the low pressure. From high pressure, wind will also blow in this particular direction. So you'll see this wind is going to be called as what? This wind is going to be called as a westerlies. Now, when the wind will travel closer to the Earth's surface, what will happen? It will get heated. Clear? So earlier when wind was moving away from the Earth's surface, it cools down. That's why it was subsiding. Now wind is okay traveling closer to the Earth's surface. When it is traveling closer to the Earth's surface, what will happen? It will get heated. Heated means what? Heated means what? The wind will starts to rise up. The wind will starts to rise up like this. Heated means wind will starts to rise up like this. So from here you will see wind is starting rising up. Like this, wind will starts to rise up. Why this wind start to rise up? Because as the wind is traveling closer to the Earth's surface, it will get heated. Again, heating means what? Expansion will happen. So here what is happening? Air is expanding. When air will be expanding here, what is going to be formed? It is called as a low pressure. So it is referred as which type of low pressure? Subpolar low pressure belt. It is referred as which type of pressure belt? Subpolar low pressure belt. Because here again wind is rising. So rising means which type of pressure belt is going to be formed? Okay, low pressure is going to be formed. Rising means low pressure. And since it occurs in polar region, near to the polar region, that's why it is called as a subpolar low pressure belt. Fine. Fine. So again, when wind will rise up, what will happen? When wind will rise up, what will happen? As wind is traveling closer to the Earth's surface, what will happen? It will pick up moisture because it is flowing over the river, it is flowing over the lakes, ponds. So what will happen? It will pick up moisture. When it will pick up moisture, what will happen? As this wind go up, what will happen? Again, you will see what will happen. Condensation and rainfall will happen. Again, what will happen? Condensation and rainfall will happen. When condensation and rainfall will happen, what energy is going to be released? Latent heat is going to be released. Latent heat will further heat up the air. As a result, you see what? As a result, wind will further rise up. Clear? So here also, you will see as it is going, clouds are going to be formed. Rainfall is something that is going to happen over here. Fine? Fine. And lastly, you see what? You see the here you see which here you will find polar high pressure belt. Here you will find which type of belt? Polar high pressure belt. High pressure belt. So in polar region, since sunlight is not reaching, when sunlight is not reaching, what will happen? In polar region, when sunlight is not reaching, what will happen? You will see here air will start to shrink or air will start to subside. Here in polar region, what is happening? The sunlight is not reaching. Sunlight is not reaching means what? Things are going to be colder. Colder means what? Then the air will subside. So here also you see air will what? Air will subside. When subside means which type of pressure is going to be formed? high pressure are going to be formed. That's why here we have written which type of pressure belt? High pressure belt. Okay, so when air will subside, because air is cooling down. Okay, polar region, no sunlight. No sunlight means air is cooling down. Air is cooling down means air will come down. So when air will come down, you will see formation of what? You will see formation of high pressure belt. Now you know that from high pressure to low pressure, what is going to happen? A wind will blow. From high pressure to low pressure, what will happen? A wind will blow. Now this wind is called as what? This wind is referred as easterlies. This wind is referred as what? Easterlies. This wind is referred as a easterlies. Fine. Now easterlies, when it is okay, what? When it is okay traveling closer to the earth's surface, again it will start to pick up certain heat. As a result, it start to rise up. And here, when you see this will okay rise up, it will again diverge into two direction. It will again diverge into two direction. Why it will diverge in two direction? Why it will diverge into two direction? Why you are seeing when air here is rising is diverging in two direction? Because again this air cannot reach into which is sphere? Stratosphere. So as a result, divergence will happen. Okay, so this air will diverge one this side and one this side, intensifying the high pressure over here, and here intensifying the high pressure over here. Similarly, here also, when air will diverge, it will intensify high pressure over here. It will intensify high pressure over here. Fine. So that's why these two pressure belt. That's why these two pressure belts, subtropical high pressure belt and subpolar low pressure belt, are referred as which type of pressure belt? Dynamically induced pressure belt. It is referred as which type of pressure belt? Dynamically induced pressure belt. Fine. Why dynamically induced? Why dynamically induced? Ideally, which region is receiving more sunlight? Tropics region or polar region? Tropic region is receiving more sunlight. So ideally, more sunlight means what? More heating. More heating means what? Low pressure should be formed over here and high pressure should be formed over here. But opposite is happening. Here you see high pressure is being formed. Here what is happening? Low pressure is being formed. So that's why it is called as what? It is called as a dynamically induced pressure belt. Fine. Any doubt regarding this one? So ideally, we have discussed what? We have discussed tropics region receives more amount of sunlight. When tropics region receives more amount of sunlight, what will happen? When tropics region receives more amount of sunlight, what will happen? What will happen? It should get high, it should get low pressure. It should get low pressure because more amount of sunlight means more heating. More heating means what? It should get low pressure. Here low pressure should be formed, here high pressure should be formed because it is receiving lesser amount of sunlight. But this is actually not happening. Opposite is happening. Here you are seeing high pressure and here you are seeing low pressure. That's why we are seeing it is which type of pressure belt? It is a dynamically induced pressure belt. It is forming because air here is rising and subsiding, and it is forming because of what? Because of nothing but okay, wind coming together, wind getting heated, rising up, and as a result, okay, low pressure is something that is okay being formed over here. Clear? So this is how the formation of pressure belts are going to be there. So we discussed this extend from where to where? From 10 degree north to 10 degree south. Now this extend from where to where? From 23.5 degree to 35 degree. This extend to from where to where? From 45 degree to 66.5 degree. And this is extending from where to where? From 80 degree to 90 degree. This is how the extension of pressure belts are going to be there. Fine. So again, here, when the air is coming here and subsiding, which type of air is coming and subsiding? From here, when air is coming and subsiding over here, which type of air is subsiding? Dry air. Yes, okay. So here it has created a rainfall. So again, dry air is something that is okay coming and subsiding. So as a result, again, which type of conditions here are going to be formed? Anticyclonic conditions here are also going to be formed. Anticyclonic conditions here are also going to be formed. So wherever high pressure belt are there you are seeing which type of condition? Wherever high pressure belt are there you are seeing which type of condition? Anticyclonic condition means no rainfall will happen. Wherever low pressures are there you are seeing which type of condition? Rainfall condition or cyclonic condition. Clear? So rainfall condition or cyclonic condition. This is also referred as the cyclonic conditions. So wherever low pressures are there you see cyclonic condition. Wherever high pressures are there you are seeing which type of condition? Anticyclonic conditions. Fine. Fine. Anyone, any doubt? So how these pressure belts are being formed? These pressure belts are being formed because equatorial region is heated. Because of heating, air will rise up. Here what will happen? Condensation happens, rainfall happens, air becomes dry. But when condensation is happening, what heat is being released? Latent heat is being released. It is further heating the air up. But this air will not move into troposphere. This air will not move into stratosphere. Why it will not move in stratosphere? Because here less dense air is there, here more dense air is there. As a result, this air will diverge. This air will diverge. Since it is moving in upper atmosphere, it becomes colder. When it becomes colder, it starts to subside in this region, which is called as a subtropical high pressure belt region. Fine. Any doubt regarding this one? And same here. Here what is happening? Because of the colder condition, you see wind here is subsiding. When wind here will subside, high pressure. As a result, you will see meeting of these two winds. When these two winds will meet, what will happen? You will see air becoming heated and air will start to rise up. Here again condensation will happen. You will see again divergence is going to happen. So this is how the pressure belt formation happens. Clear? So that's why these pressure belts are present throughout the year, and that's why these pressure belts are called as a permanent pressure belt. These pressure belts are called as what? Permanent pressure belt. Clear? Why? Because these pressure belts are present throughout the year. That's why they are referred as what? Permanent pressure belt. And that's why these winds are also referred as what? These winds are also referred as what? Permanent wind. Because pressure belts are permanent. What will happen? Wind will also blow, and these winds are going to be called as which type of wind? Permanent wind. That's why easterlies, westerlies, northeast trade wind, southeast trade wind are referred as what? They are referred as a permanent wind. They are referred as which type of wind? Referred as a permanent wind. So northeast trade wind, southeast trade wind, westerlies and easterlies, they are referred as which type of wind? They are referred as a permanent wind. Fine. Fine. Now you see from here the air is rising up. This is how the air is rising up. Then air is diverging in which direction? This direction. Air is then subsiding and then moving like this. Clear? So it is making what? It is making a complete circulation. Here also the same thing is happening over here in the northern hemisphere also. You see air rising up, moving in this direction, then falling and then coming in this direction. Again this complete circulation is called as what? This complete circulation is called as a Hadley cell. This complete circulation of air is called as a which cell? They are referred as a Hadley cell. So this complete circulation of air rising from equatorial region, moving and then subsiding, then coming back, this complete circulation is called as which type of cell? Hadley cell. Fine? Fine? Clear? Now the same thing you will also see over here. What is happening over here? Air is rising up like this. Air is rising up like this, then moving in this direction. Then what is happening? Falling like this and then coming again in this direction. So air rising like this, moving in this direction, falling like this and coming like this. Again also happening over here. Air rising like this, moving in this direction, falling like this and then again coming back like this. So this is also forming a complete cell. And this cell is referred as what? This cell is referred as a Ferrel cell. This cell is referred as what? Ferrel cell. Ferrel cell. So one cell is Hadley cell, the second cell is called as a Ferrel cell. Fine. Now the last cell that you see formation is what? Here. Now here also it is rising up, moving in this direction, falling and then coming back. This is happening over here also. This is happening over here also, rising up, moving in this direction, coming back. This is called as a polar cell. This is called as which type of cell? Polar cell. So that's why you have three cells formation, which is called as a Hadley cell, Ferrel cell, and polar cell. Any doubt regarding this one? So that's why you will find what you will find the B cell presence. There are 4 cells we are going to study in climatology. The 3 cells are D cells: Hadley cell, Ferrel cell, and polar cell. And there is another cell which is referred as a Walker cell. We'll discuss it later. We need to discuss. So Hadley cell, Ferrel cell, and polar cell. You keep in mind what is this cell? The one complete circulation of air rising up, moving in the other direction, falling, and then completing this circulation. This is called as a Hadley cell, Ferrel cell, and polar cell. Fine. Now another important thing that you have to keep in mind is wind. How the wind are being named. So here we are calling it which wind? Northeast trade wind, southeast trade wind. So here we are calling wind as what? Northeast trade wind, southeast trade wind, westerlies, easterlies. So how the winds, how we are naming these winds? How we are naming these winds? Basically what you have to keep in mind is, these are your directions. These are your directions. This is north, this is south, this is your east, and this is your west. So these are your directions, okay, that you are finding. North, south, east, and west. Fine. Wind are always named after their point of origin. Clear? Wind are always named from their point of origin. So this is a nomenclature we are okay using. Wind are named after point of origin. From where they are originating, that is a name given to the wind. Fine. So if wind is originating from this region, it is which type of wind? It is which direction? Northeast direction. So if wind moving like this, it is going to be called as what? Northeast trade wind. Clear? If the wind is originating over here and moving in this direction, then it is going to be called as what? Southeast trade wind. Clear? If the wind are moving, originating and moving from here, then it is going to be called as what? Westerlies. If it is okay moving and moving from here, then it is going to be called as what? Easterlies. Clear? So this is how we name the wind. Wind are always named after their point of origin. From which direction they are originating, that's how we name the wind. So westerlies, easterlies, northeast trade wind, and southeast trade wind. These are the names that are given to the wind based on their origin direction. Fine? Fine. So now you are getting what? You are getting the 4 important pressure belt. So you are getting 4 important pressure belt. The first pressure belt we discussed is which pressure belt? Equatorial low pressure belt. So the first pressure belt that you are finding is a equatorial low pressure belt. From where to where it is formed? We discussed it is formed generally between 10 degree north to 10 degree south. It is formed from 10 degree north to 10 degree south. Which type of pressure belt it is? Which type of pressure belt it is? Thermally induced pressure belt. Which type of pressure belt it is? Thermally induced pressure belt. Fine. This pressure belt is also known as intertropical convergence zone. This pressure belt zone is also referred as intertropical convergence zone or ITCZ. This is also known as intertropical convergence zone or ITCZ. Why it is called as a ITCZ? Why it is called as a ITCZ? Because you will see which two winds are converging. Northeast trade wind and southeast trade wind, they are converging over here. That's why this zone is referred as what? Intertropical convergence zone. The tropical winds are coming and converging in this zone. That's why this wind, this layer is, or this pressure belt is also referred as the intertropical convergence zone. It is also referred by the name doldrum. Doldrum. Doldrum means what? The calm conditions. It is also known, okay, as a doldrum. Doldrum means prevailing of calm conditions. Calm conditions means what? That you don't see much movement of air. Much movement of air you don't find. That's why this is referred as what? This is referred as a doldrum conditions. Fine. Much movement of air you will not find over here. That's why this is referred as what? Doldrum condition. If you see air movement, air is blowing where? If you see air movement, air is blowing where? Till this point. Till this point air is blowing. But in this region air is not blowing. Here what is happening? Here you see current are rising, but you don't see wind movement in this region. 10 degree north to 10 degree south. Wind is moving till when? The southeast trade wind is coming till this point. Northeast trade wind is coming till this point. But in this zone 10 degree north to 10 degree south, you only see which is okay there. Rising air currents are there. And you know that when air current will rise, you don't experience it, you don't feel it. Why you don't feel it? This rising air, you don't experience it, you don't feel it. Why you don't feel it? Why do you don't feel it, rising air or rising current?
Because of the gravitation.
Because of gravitation. Yes, okay. We discussed this rising current is what? Balanced by the gravity. We just now discussed air has two movement, horizontal movement and vertical movement. Vertical movement are not experienced because it is balanced by the gravity. Only horizontal movement are experienced. Okay. So when this air is rising, what is happening? It is not being experienced. So no horizontal movement is there and vertical movement you are not experiencing. Means what will happen? What will happen? Calm conditions are going to be there. You don't see any movement. The calm conditions are going to be there. That's why it is referred as what? It is referred as a doldrum condition. It is referred as which type of condition? Doldrum condition. Because no horizontal movement of air is there. No horizontal movement of air. And vertical movement is what? Vertical movement is not experienced. Is not experienced. That's why this region is referred as what? This region is referred as a doldrum. This region is referred as a doldrum. Fine. Fine. So these important points you have to keep in mind. Another important thing, since intense convectional currents are there, intense convectional current are there, you'll see formation of cumulonimbus type of cloud. Leading to rainfall and thunderstorm. Leading to rainfall and thunderstorm. Since intense convectional current are there, it will, which type of clouds are being formed? Cumulonimbus. Okay, what is cumulonimbus type of cloud? We'll take up later, but just right now remember that these clouds have a very big height. These clouds are not like this. These clouds are having a very big height. Fine. For example, here how do you see this is rising? You will see air is rising like this. When air is rising like this, clouds are going to be formed in a vertical manner. Okay, so they are going to be formed in a vertical manner, and such type of clouds are referred as what? Such type of clouds are referred as a cumulonimbus type of cloud. When this type of clouds are being formed, you will see intense rainfall and thunderstorm is going to be there. Fine. That's why equatorial region is known for what? Equatorial region is known for intense rainfall generally between 2 to 4 pm. It is generally generally known for intense rainfall between 2 to 4 pm. You see equatorial region will see that particular rainfall. Fine. Fine. Any doubt regarding this particular thing? So intense rainfall, why you'll see? Why you'll see intense rainfall? Because during the daytime till 2 o'clock what will happen? Earth will get heated. When earth will get heated, what will happen? Convectional current will rise up, air will rise up. When air will rise up, what will happen? Cooling condensation will happen. Cooling condensation means what will happen? Rainfall will happen. Clear? So that's why you will see rainfall in equatorial region. That's why rainfall in equatorial region is throughout the year. Rainfall is throughout the year in equatorial region. In India, you have what? In India, you have a monsoon season. Monsoon season means much of the rainfall is what? Much of the rainfall you see in the monsoon period. But in equatorial region, you will see rainfall happening throughout the year. Fine. Fine. So these are the important points you have to keep in mind with regard to what? With regard to equatorial low pressure belt. This equatorial low pressure belt extends from 10 degree north to 10 degree south. Thermally induced pressure belt, also known as intertropical convergence zone, as it is zone of convergence of northeast trade wind and southeast trade wind. It is a zone of convergence of northeast trade wind and southeast trade wind. Doldrum condition, calm conditions are there because no horizontal movement of air, only vertical movement of air are there. Intense convectional currents are going to be there due to formation of cumulonimbus type of cloud. And generally you will see frequent rainfall in the afternoon around 2 to 4 p.m. and rainfall happens throughout the year. It's not like it is concentrated as you see in case of India. Fine. Now the second type of pressure belt that you have is a subtropical high pressure belt. Subtropical high pressure belt. One more thing, since here no air movement is there, in here we are saying that calm conditions are there. Air is not moving, horizontal air is not moving. So when horizontal air is not moving, you don't see formation of what? You don't see formation of cyclones in this region. Why? Because for cyclones you requires a wind, okay, wind to move. But in this region, since wind is not moving, you don't see formation of what? You don't see formation of cyclone in this condition. So you see no cyclones are formed. No cyclones are formed in equatorial regions. Why? Because winds are not there. For cyclone to form, you need a wind. But here the wind are not blowing much, and that's why no cyclones are going to be formed in equatorial low pressure belt region. Fine. Second is a subtropical high pressure belt. You'll see it is extending from 23.5 degree to 35 degree north. This is a general extension of high pressure belt. It is a which type of pressure belt? Dynamically induced pressure belt. It is which type of pressure belt? Dynamically induced pressure belt. Also, which type of conditions you are going to see? Anticyclonic condition. Anticyclonic condition, no rainfall. No rainfall due to subsidence of dry air. Subsidence of dry air coming from equatorial region. Due to subsidence of dry air coming from equatorial region. Fine. The other important part that you see is this region is also referred as a horse latitude. This region is referred as a horse latitude also. So 23.5 to 35 degree. This region is referred as a horse latitude also. Fine. Now, if you look at India, right? This is how you're going to find the map, and what happens is what happens is this region is where equator is there, and this region is where subtropical high pressure belts are there. Clear? This region is where subtropical high pressure belts are there. We discuss which wind blows over here. Which wind blows over here? Which wind blows over here? Northeast trade wind. Okay, so we discussed this is a subtropical high pressure belt zone, and this is what? Equatorial low pressure belt zone. So which wind is going to be low over here? Northeast trade wind. Clear? So as a result, this region basically what you see is, let's say in ancient time you have studied about port and etc. Clear? Ancient port, trading used to happen in Harappan civilization, other civilization. How trading used to happen over there? How trading used to happen? At that time you don't have advanced technology, no? Advanced technology means, okay, you don't have the, the motor boats and etc. that is okay there. Whatever the boats that you have is what? You have to row the boats. Clear? So wind, if you have to row the boat in the direction of wind, and if you have to row the boat against the direction of wind, what will happen? Which is more easier? You have to row the boat in the direction of wind, or if you have row the boat against the direction of wind, which is easier? In the direction of wind. Yes, wind aids the movement, and as a result, if you are rowing the boats in the direction of wind, then it becomes easier. So that's why when they used to come with the boat, and when they used to what? When northeastern trade wind used to blow, what will happen? They used to take goods and move away from India. That is okay there. So this is helping in trading. That's why we call it as what? Trade winds. Okay. That's why the name is given as what? Northeast trade wind. Trade wind is what? Because whenever traders used to come India and take goods away from India, this wind used to help in trading, and that's why it is called as what? It is called as a northeast trade wind. But what about this region, subtropical high pressure belt region? This region, as we discussed, no wind are blowing in this region. When no wind are blowing in this region, what will happen? What will happen? Rowing becomes difficult in this region, okay, because wind is not aiding your movement. So rowing becomes difficult in this particular region. As a result, whenever traders used to come from, let's say, Persia region, another region, when they used to reach this particular region, they found difficult to row the boats. They found difficult to row the boats in this particular region because no winds are there. No winds are blowing in this region. If you see this region, so if you are seeing this subtropical high pressure belt region, either you are seeing wind blowing northeast trade wind beyond 23.5 degree, or you will see nothing but okay beyond 35 degree, that is okay there. In this region, what is happening? No wind are something that are blowing. When no wind are blowing, what will happen? Difficult to row the boats in this particular region. Clear? And if you study history also, you will find that many of nothing but okay southern empire used to trade in horses. They used to trade in horses, like Vijayanagar Empire. You'll see they used to bring good quality of horses from Central Asia. Okay, Bahmani's kingdom. Even before that, Cholas, Chelas, Pandyas. Okay, they used to bring good qualities of horses from Central Asia. So they used to have trading in horses from foreign countries. So these horses were used to be brought through the boats. They used to be brought through the boats and etc. And with the horses on the boat, it becomes very difficult to row the boats because already wind is not there. It becomes difficult, and with additional weight of horses on the boat, it becomes very difficult to row the boats. So when traders used to reach in this region, what they used to do is what? They used to tie the horses with the boat and throw them into what? Throw them into water. And when they cross this region, they used to pull the horses back onto the boat. Okay, that is okay there. This allows them to move and do the trading, and that's why this region is referred as which type of latitude? Horse latitude, because horses used to be thrown and then brought back into the boats. Okay, that is okay there. Clear? So that's why this region is also referred as a horse latitude region. Fine? Fine? Now, this is a subtropical high pressure belt is the reason where you will find lot of deserts. Hot deserts are found in this region. Hot deserts are found in this region due to anticyclonic conditions. Anticyclonic condition. And also you will find maximum temperature are recorded on Earth in tropic region, in the subtropic region. Maximum temperature on Earth are recorded on Earth in subtropic region also. That thing also we are finding in a subtropical high pressure belt. Why maximum temperature recorded on the subtropic region? Why maximum temperature is being recorded in a subtropic region? Why not equator region? Because equator also receives huge amount of sunlight. Cool oceanic currents. Okay. Any other reason?
The air is
Cool oceanic current will reduce the temperature or will increase the temperature?
Pressure will be increased.
Any other thing?
like it will lose the moisture, the air, and it will move away from the ITCZ zone where the temperature will increase.
Fine. Any other reason? As we discussed, equatorial region, see what? Intense heating happens in equatorial region. No sunlight are there. But what is happening is, okay, as we discussed, as soon afternoon happens, what will happen? Rain is there, cloud formation is there. So as a result, okay, remember, heat budget, we discussed cloud reflects what? Sunlight. Cloud reflects sunlight, okay, that is okay there. So heat budget we have discussed, no? What are the things that are reflecting the sunlight? Clouds are reflecting, we discussed dust particles, Earth's albedo, that is reflecting the sunlight. So we discussed clouds are being formed, clouds are reflecting the sunlight and etc. in equatorial region. But here, in this region, no rainfall is happening. When no rainfall means no cloud is being formed. So this region receives continuous sunlight and no rainfall, no cooling conditions are there. That's why maximum temperature on Earth is recorded where? Recorded in the tropics region, not in equatorial region. Equatorial region receives more amount of sunlight, but what you see is, okay, their cooling conditions is also there due to rainfall, due to formation of clouds, but that is not present over here. Fine. So that is the reason why you see maximum temperature, okay, is recorded. Like maximum temperature on Earth is recorded is 58 degrees Celsius till now, and that is recorded in Algeria. Where is Algeria? Where is Algeria? So you find African countries. So okay, so here you find nothing but, okay, the Algeria, Morocco, all those particular countries. So again, this lies in which region? This lies in tropics region. This is your equator region. This is where Tropic of Cancer is passing. So it lies where? In the tropics region. That is what you are finding. So that's why subtropical high pressure belt do not see any type of rainfall. When you do not see any type of rainfall, what is formed? Deserts are formed over here. And you will also see maximum temperature are recorded in this particular region. Fine? Fine. The next pressure belt that you have is what? The subpolar low pressure belt. Subpolar low pressure belt. Generally you will see extension of subpolar low pressure belt from 45 degree north to 66.5 degree north. Generally you will find this pressure belt between 45 to 66.5 degree north, and this pressure belt is more pronounced in northern hemisphere as compared to southern hemisphere. So it is more pronounced in northern hemisphere as compared to southern hemisphere. Fine. Why it is more pronounced in northern hemisphere as compared to southern hemisphere? Why it is more pronounced in northern hemisphere as compared to southern hemisphere? It is because you will see what? You will see beyond, okay, what? Beyond 40 degree latitude. In the southern hemisphere, what is there? Oceans are only there. No land mass are there. Clear? Only oceans are there. You will find, okay, this is how Southern America is there. This is how Australia are there. Beyond this, what is happening? No land mass are there. Only oceans are there over here. Fine. So as a result, you don't see much of, okay, what? Much of variation in the southern hemisphere. That's why we are writing it is more pronounced where? In the northern hemisphere as compared to what? As compared to southern hemisphere. Clear? Because in northern hemisphere we have a land mass, but in southern hemisphere we only have oceans over here. So that's why we have written it is more pronounced in northern hemisphere as compared to southern hemisphere. Fine. Second important thing, what you have to keep in mind is during winter you will see break in this subpolar low pressure belt due to presence of presence of oceans or water in northern hemisphere, and that's why there it is referred as Icelandic low or Aleutian low. Icelandic low or Aleutian low. So during winter what is happening? This subpolar low pressure belt do not become continuous. It do not becomes continuous. Like it will not be continuous like this. It will be breaking. Breaking means like this it will break down. Like it will break down. So it will form over certain island which is called as the Icelandic low or Aleutian low. Okay, so it is formed over island. So that's why referred as a Icelandic low or Aleutian low. Fine. So this is okay. Another part that you have to keep in mind with regard to subpolar low pressure belt. So more pronounced in northern hemisphere as compared to southern hemisphere. During winter in northern hemisphere, you generally see a break in subpolar low pressure belt. Why you see a break in subpolar low pressure belt? Because of what? Because of nothing but okay, the oceans or water, and there it is referred as what? Icelandic low or Aleutian low. Fine. Then you will also see what? Then you will also see the subpolar low pressure belt is also a zone of meeting of two contrasting wind. Zone of meeting of two contrasting wind. Two contrasting wind. That is westerlies and easterlies. Westerlies and easterlies. That's why you'll see formation of temperate cyclones. Temperate cyclone formation. You'll also see rainfall in this region. Cyclonic conditions in this region. So that you will find in case of what? In case of subpolar low pressure belt. So it is a zone of meeting of two contrasting wind. What are the contrasting wind means? The temperature is changing of wind, pressure is changing of wind. So that's why you will see a zone of meeting of two contrasting wind, westerlies and easterlies, leading to what? Leading to temperate cyclone formation or intense rainfall formation. Fine. So this is okay, important thing that you have to keep in mind. So it is more pronounced in what? More pronounced in northern hemisphere as compared to what? Southern hemisphere. During one more thing, sorry. During summer, not winter, right? During summer, there is a break in subpolar low pressure belt due to presence of ocean or water in the northern hemisphere, referred as what? Referred as the Icelandic low and Aleutian low. It is a zone of meeting of two contrasting wind, westerlies and easterlies. And lastly, temperate cyclone are being seen over here, or cyclonic conditions are being observed. Fine. Now, if you look at map, Now, if you see this map, so what you are finding in this map is this region we discussed here is 45 degree north. You can see this region is written as what? This is written as 45 degree north. 45 degree north, and this is okay what? This is 60 degree north. You can see this is written as a 60 degree north. That is okay there. Clear? So we discussed generally what happens is what? Generally what happens is that extension of what? Extension of the subpolar low pressure belt is in this range. Extension of what is there? Subpolar low pressure belt. We have written 45 to 66 and a half. So extension of subpolar low pressure belt is in this region. That is okay there. Clear? Now during summer what happens? Sun position is where? During summer in northern hemisphere, sun position will be where? At the Tropic of Cancer. When sun will be at Tropic of Cancer, what will happen? You see, land part is what? Land part will get more sunlight. When land part will get more sunlight, what will happen? What will happen? You will see low pressure formation, while the oceans will get what? Oceans will get what? Oceans will get what? As we discussed, land get heated quickly also and cools down quickly also. Oceans, what will happen? Takes times to heat and takes times to cool down. So while the land get heated quickly, here low pressure is going to be formed. At the oceans, what is going to be formed? High pressure, because it takes times to heat and times to cool down. So here high pressure are going to be formed. So that's why we see breaking off, what? Breaking off nothing but the things happen. Subpolar low pressure belt breaks down. It is not continuous. It breaks down because in between high pressure is formed due to the presence of nothing but oceans in this particular region. So that's why you see breaking of this one. And here you will find Iceland, and here you will find what? Aleutian Island. This is referred as what? Aleutian Island, and this is referred as a Iceland. Okay. So we discussed in these regions. This is the land part. Land part means what? Get heated quickly. When land part will get heated quickly, what will happen? Low pressures are going to be formed. So that's why these are referred as what? Icelandic low or Aleutian low. That's why these are referred as what? Icelandic low or Aleutian low. Why? Because low pressure are something that are being formed over here. Clear? So this is what you have to keep in mind with regard to subpolar low pressure belt. And here you see, as we discussed, this is okay what? This is okay, your 45 degree. Beyond 45 degree, you will see only oceans only. You only see this much of land mass. Okay, you will see mainly oceans only. Only till what? Till nothing but 66.5 degree. You will find oceans only. So when oceans are there, what will happen? That is the reason why we are saying subpolar low pressure belt are not much pronounced where in the southern hemisphere. They are more pronounced where in the northern hemisphere. Fine. Any doubt regarding this particular part? So this part you have to keep in mind with regard to the high pressure and low pressure formation. The last pressure belt that you have is a polar high pressure belt. Last belt that you have is a polar high pressure belt. So where do you see formation of polar high pressure belt? What is the extension? What is the extension of polar high pressure belt? 80 to 90 degree. Polar high pressure belt, you will see extension 80 to 90 degree. Generally you will see in Arctic and Antarctic region. Arctic and Antarctic region. As we discussed, high pressure means what? High pressure means what? There will be less anticyclonic conditions are going to be there. High pressure means anticyclonic conditions are there. Very less rainfall. Anticyclonic means rainfall will be very less rainfall, and mostly rainfall happens in the form of snow. Whatever rainfall will happen in the form of snow, not in the form of water. Very less rainfall happens in this particular region. Clear? Now, it is thermally induced pressure belt. Thermally induced pressure belt. Extremely cold conditions. Extremely cold conditions, and that's why difficult for survival of humans. So humans, difficult for the survival of humans. Extremely cold conditions are something that are present. Fine. So these are what? These are the different type of pressure belt that you are finding. Clear? Equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, and polar high pressure belt. Fine. Equatorial low pressure belt is also referred as which one? It is also referred as ITCZ, Intertropical Convergence Zone. It is also referred as what? Doldrums. Fine. The subtropical high pressure belt is referred as what? Horse latitude. It is also referred as what? It is also referred as a horse latitude region. Fine. We discuss subpolar low pressure belt is which kind of pressure belt? It is thermally induced or dynamically induced? It is a dynamically induced pressure belt. Fine. Where do you see, in which pressure belt you see Icelandic low and Aleutian low? In subpolar low pressure belt, you will see Icelandic low and Aleutian low. Fine. So those things you have to keep in mind with regard to pressure belt. So why pressure belt is originating? What is the reason? You see formation of all these pressure belt we have discussed. Now 3 cells also we have discussed. What are the 3 cells we have discussed? Hadley cell, Ferrel cell and polar cell. Clear? So the complete circulation of air that is rising, moving apart, falling and then merging. This complete circulation is referred as a cell, and 3 cells we have discussed. Hadley cell in tropical region. Hadley cell, you can from where to where Hadley cell moves. Hadley cell is between equatorial low pressure belt and subtropical high pressure belt. So between equatorial low pressure belt and subtropical high pressure belt is a Hadley cell. Ferrel cell is between whom? Subtropical high pressure belt to subpolar low pressure belt. So here you will see formation of Ferrel cell. And lastly, you have what? Polar cell. Polar cell formation is from where to where? From subpolar low pressure belt to polar high pressure belt. We'll see formation of polar cells. Fine. So these 3 cells formation also you keep in mind where they are being formed. Yeah. So that's why you will also see so that's why we discussed with this high clouds are being formed. Which type of these high clouds are there? So this high clouds are being formed, and this high clouds is which type of cloud? Cumulonimbus cloud. We just now discussed what type of clouds are going to be formed. Cumulonimbus type of clouds are going to be formed. So this cumulonimbus cloud are which type of cloud? Vertical cloud. We discussed which type of clouds are going to be formed? Vertical cloud. And we discussed this cell is referred as which cell? Hadley cell. This cell is referred as which cell? Ferrel cell. This cell is referred as which cell? Polar cell. So that is why you are seeing these 3 types, and that's we discussed between tropical and temperate, that is mid latitude region. We'll see Hadley cell, Ferrel cell and polar cell. So that is why 3 cells formation you are going to see. So this is how 3 cells formation are something that are happening. Fine. Have a break. And this one more thing, there is a term that is used called meridional circulation. What is this meridional circulation? This entire cell, these 3 cells referred as what? This is 3 cells are referred as what? Meridional circulation. These cells are referred as what? Meridional circulation. Why meridional circulation? Why meridional circulation? Because they are what? They are helping in transfer of what? They are helping in transfer of moisture, heat from one location of Earth to another location. From one location of Earth to another location. So that's why these are referred as what? These are referred as a meridional circulation. Fine. So what is the importance of meridional circulation? They are helping in transfer of what? Transfer of moisture. They are helping in transfer of heat from one location of Earth to another location. You know that equator region receives more sunlight. So hot condition. Here what is happening? Colder condition. So how this colder wind comes over here. As a result, colder winds are coming over here, and from here the hot winds are going over here. Mixing of wind is happening from one location to another location, and this results in what? This results in moisture of exchange of moisture, exchange of heat from one location to another location of Earth. Clear? So that's why, if you remember, we discussed what is the average temperature of Earth. What is the average temperature of Earth? We discussed 15 degrees Celsius, but because of the greenhouse gases and etc., it is now increasing. So we are trying to now control this global warming to how much Celsius? From up to 16.5 degrees Celsius. So how this average temperature of Earth is being maintained? This average temperature of Earth is being maintained due to this circulation only, which is called as what? Meridional circulation. So excess heat from this region is transferred over here. Excess cold from here is transferred over here. This circulation is referred as what? This circulation is referred as a meridional circulation. Fine. Have a break. We will continue.
అమ్మాయిలు ఎలా ఉంది? సరే సరే. అక్కడికి వెళ్ళి ఆ స్లైడ్స్ ఓపెన్ చేయాలి. Pause చేయాలి.
Fine. So force that is generated due to rotation of Earth is referred as what? Is referred as a Coriolis force. Fine. And
Okay.
so northern hemisphere and southern hemisphere, we are saying it is moving on the right hand side and it is moving on the left hand side. That is due to Coriolis force. Now, another important thing that you have to keep in mind is, because we discussed equator region, the point has to move what? Point has to move more distance, and in polar region what is happening? Point has to move lesser distance. Polar region, as you are going, point is moving lesser distance. In equatorial region, point has to move what? More distance. Okay, that is okay there. That's why the Coriolis force varies